So guys, welcome. I want to show you how to make converter, an analog converter on S7 Manager. If you're having an analog signal, e.g. analog signal coming from a boiler, which will read the temperature, the current temperature of the boiler. So there is a thermocouple on the boiler that transmit an analog data to your analog module on your PLC. This signal, this data in raw form cannot be processed by the CPU. Thereby, you need to convert it to what the CPU can understand to process data, to process event, to maybe to activate a tank, to activate a valve, to activate a pump and the likes. So let's get straight to work. So let's create a new project, call it boiler scale converter. So open. So we are using a S300 station, a Simatic 300 station. We have different type of PLCs. So let me add my Simatic 300 station. So the first thing we do is we do the hardware configuration of the PLC. So because of our time, we won't be adding all the components. So we'll just be adding our CPU and an analog module that our thermocouple from the feed will be connected to. So first, let's add our rail or rack. So the first slot is for the power. We don't need that right now because we are not using a station. We'll be using a stimulator. It works exactly the same way. So you can do this also. It's almost the same thing on TIA Portal. It's almost the same thing, only that TIA Portal is more graphical, has more graphic user interface than S7 and WinCC, if there will be a need to do that. So let's add our CPU. Let me add a CPU that I'm very familiar with. So let's add that. This CPU has a Profibus network, but we don't need that right now. Just if you want to know how to do a Profibus connection, you can comment. You can put a comment. You can reply in the comment section. I will actually put it through, maybe, or do a video on that, or you can have a private class. So here, let's add our analog module, our analog input module. So AI input module for S7. Let me add this. I'm familiar with this too. So let's now do the configuration of this analog input module. So we are using the transistor we are using is a voltage 2-wire voltage transistor for an example. So it has a reading of 0, minus 0, plus 0 to 10 volts. That's signal coming from it. So I think that's all there. So another thing, let's just check this address 256. That's our first input. That's our first input. We are using, if you want to use more than one, there's another thing. If you want to use more than one thermocouple or a analog transmitter from the feed, and you want to use more than one, I will explain how the address allocation is. The address allocation here, how it will be. There's an explanation surrounding that, but because of our time, we can't actually talk about that right now. If you want an explanation too, you can comment. I will give you an in-depth explanation about how this address is. There are some terms around this module, serial number and the likes. There are terms around that, but let's go straight to what we are here to do today. Save and compile this. So when you are done, you can close it. So open your CPU and block. So I'll be writing this program in our OB1, and we'll be using it in a large language. Large language is large language is a language that everybody who is into programming of PLC understand. So you knowing STL just shows that you've evolved, you've known more, and STL to me to what I've seen both on practical, those who have practiced on the field as an engineer, STL is more powerful and more resourceful than LAD. But if you understand this in LAD, you can actually transfer it to STL. So let's open, and to convert an analog signal coming from a feed, we have a function for it already in your S7. Is also in TIE Portal. It is called FC105, which you can find in standard library, and you can find it under this. If you open standard library, this is how it is. So you come here, IEC function blocks. So TI S7 converting block. So the name of the converting block is FC105 scale convert. So you just drag it and put here. So what this one really, let me explain this one. This is the address of your analog, the address of the analog signal, the address where you put your analog signal on the analog input module, which is 256. That's the first one we are using. There are other ones that you can use, but we are using 256. The other address that you can use, if you want more explanation on that, so you comment. So another thing is we have high limit and low limit. This high limit just means that, so we are using a boiler. Let's assume your boiler read between 0, the lowest temperature you can read is 0 degree and the highest is 100 degree. Definitely your high limit is 100 degree. It can be 1000 degree. It can be, it's just an example, is 100. So you input 100.0, enter. So your low limit is 0.0, enter. Here just you can put a memory, or I'll put an input, can put a switch or a button. I1, that's an address on my own module. I1.4, just I1.1, let me use that. So your return value is, if this conversion encounter an error, what is where it will be saved is your, and that is a word. So MW2, let's use that, and your output is in double integer, or it can be in integer, but it's in double integer. So you put MD4 23 is equal to MD. Let's use MD10 because of, to avoid address conflict. So here it is, we are done. Let's save. So let's test run this right now. So let's go to our stimulator. So let's open the stimulator. Okay, sorry, my stimulator is already open there. So let me launch it again. Let me launch my stimulator. I don't want this video to go beyond maximum 11 minutes. So this is our stimulator. Let's pin this one to here. So let's download our program. Please pick this. Just okay, it's right. Yes, download. Oh, sorry. Sorry, we have to change our set PG interface to align with this. So let's speak MPIC now. Okay, we're done there. So we've downloaded our program. So let's just go straight to so let me input this, input variable, input. So let's put our address PIW 256, right? 256. So let's just put it to a slider, integer. So let's open our OB1 to monitor our program. So let's start around the program. So I want you to look at, so since the EAA is on 0 now, so the current value is 0. Just watch as I increase this slider. Can you see? This is the raw data coming from the feed. You see, this is the raw data coming from the feed. But if you want to equate this data to the current temperature of your boiler, that means your current temperature of your boiler is 28.215 till you get to, you see, so that's how to convert your analog signal. So from here you can pick this your output value, you can compare it, maybe compare it with this actual value. When you get to this level, stop the heat generation, stop this, start the conveyor, open a valve and the likes. Thank you for watching. Remember to like and subscribe to the video. If you have any question, you can put it under the comment section, or you need any guide or tutorial on any aspect of Siemens PLC or Allen Bradley or a Mitsubishi PLC. I'm willing to provide help, even if it is on hardware, physical hardware. I'm willing to provide help. Thank you for watching.